Let us take an important derivation. It is left out actually in the electric field. Torque means movement of the couple on a dipole. So an important derivation. Sometimes it will be asked in the examination. You know that what is the dipole? Dipole is two equal and opposite charges plus q and minus q. Minus q and plus q separated by a distance 2a. The distance is called axis of the dipole. Okay, and it is the system of two equal and opposite charges. Two charges equal in magnitude but opposite in polarity, separated by a small distance 2a, is called a dipole. This system itself is called a dipole, and there is a dipole moment. A physical quantity is associated with a dipole. What is that physical quantity? Dipole moment. That is dipole moment P bar is equals to 2aq. P bar is equals to 2aq into P cap. Okay. So what is P cap? P cap is unit vector in the direction of what? Minus q to plus q. P cap. The direction of the direction of the dipole moment. P bar is equals to from minus q to plus q. I told you this is the magnitude of the dipole moment. Simply P indicates only magnitude. P bar means magnitude and direction. Bar is taken as magnitude and direction. Simply P indicates magnitude. Magnitude of the dipole moment is 2aq, and its SI unit is q is in coulombs and it is meter. Coulombs meter. Okay, and direction of this dipole moment is from minus charge from minus q to plus q along the axis of the dipole. Okay, this 2a is called axis of the dipole. So coming to one movement of a couple or torque movement, what it is, or movement of a couple or torque. What is this physical quantity? Last year I studied. Look here. Here two forces. One is F bar, another one is minus F. Acting on an arm AB. Acting in an arm AB, two forces, one is plus F and another minus F, acts on the arm AB. The arm will be rotated. So the rotational effect is called the torque. The rotation effect of the couple, this is called couple. Two equal and opposite forces is called and separated by a distance. That's called a couple. This couple actually rotates the arm. For example, churning rod. Churning rod. With the help of the churning rod, what it is? The churning. Churning. You know that the churning rod is rotated with the help of what? What it is? Strings. One string is pulled backward, one string is pulled forward. Or best example is rotation of what? The floor wheel by the belt. The one belt is dragging it in the forward direction, one is pushing in the backward direction. Two equal forces, minus F and F, rotates the body. Due to the torque, the body will be rotated. So this is torque due to two equal and opposite forces. Therefore it is torque due to a couple or torque. Another name is for the torque is movement of the couple. Couple means two equal forces, equal in magnitude and opposite in sign. Okay, opposite in direction. Those two forces acting on a body at with a separation where two forces are not acting at a point. So both the two forces are acting at a certain distance on the body. Then the force rotates the body. That rotation is called as torque on a dipole. Okay. So here, so we know that what the torque, what is the movement of the couple? Movement of the couple formula is denoted by tau. Movement of a couple or torque is denoted by tau. That's equals to the perpendicular distance between the AB, perpendicular distance between the two forces into the force, magnitude of the force, F into AB. You know that F into AB. As a vector rotation it is concerned, it is F bar into AB bar. Okay, F into AB bar. So F into, that is the what it is. F into AB bar is not taken, so it is F bar into AB bar. The F bar cross AB bar, torque toe bar is equal to F bar cross AB bar is the torque due on a body due to the two equal equal and opposite forces, that is due to a couple. That torque rotates the body actually. Torque rotates the body. So let us consider now the torque on a dipole. So here is the dipole. Okay, dipole minus q and plus q kept in an torque moment of the couple on a dipole in an electric field. That point is to be taken in reading. In an electric field, kept in an electric field. Kept in an electric field. And the dipole is kept in an electric field. Okay, electric field. So here is a dipole minus q plus q. Dipole means two equal and opposite charges. So separated by a distance 2a, is kept in an uniform electric field E bar. So when any charge is kept in a field, then force will be acting. What is the force? F is equal to magnitude of the force. F is equal to q into the charge into the field. So any charge is kept in a field, then force will be acting on the charge. What is the electric force? F is equal to q into field. Okay, so two forces are now acting on plus q, a force. F bar is equal to q into E bar in the direction of the field. Look at the direction of the force in the direction of the field. That is the theory given. It is already mentioned. If the charge is positive, kept in a field E bar, then the force is F is equal to q into E, and this force will be in the direction of the field. Charge is positive, the direction of the force on the charge is in the direction of the field. Okay, the direction of the force and direction of the field will be same. The charge kept on in the field is positive. If any charge, positive charge or negative charge, is kept in an electric field, on that charge force will be active. How much is the force? F is equal to q into E, magnitude of the force. So what is the direction of that force? If the charge is positive, then the force will be in the direction of the field. If the charge is negative, then the force will be in the opposite direction of the field. Field is upward, the force is downwards. Look here. So that's why on plus q, a q E bar is acted in the direction of the field, F bar, and on the charge minus q. So a force minus F bar is equal to minus q into E bar. That is the formula for force. F is equal to q into E. So it is acting in the opposite direction. Look here, the direction of the force minus F bar. It is in the opposite direction of the field E bar. And F bar on the charge plus q is in the direction of what? E bar. Okay. So these two forces, look here, are equal in magnitude. QU, QV are the magnitude actually, and are in opposite direction. So constitute a couple. And this couple actually rotates the body, rotates the dipole, will rotate the dipole, and hence when rotational effect is called torque, there will be a torque on the dipole. Why torque on the dipole? Because two forces are acting on the dipole, on the charges of the dipole, plus q and minus q. These two forces are equal in magnitude and opposite direction, and these forces are separated by a distance, with the perpendicular distance between the charges, forces, perpendicular distance between the forces. This is here OB. OB is the perpendicular distance between the forces. So if there is a separation between the two forces which are equal in magnitude, opposite in direction, and acts on a body, then the body will be rotated. That rotational effect itself is called torque. Okay. Now with all these setup, initially suppose the angle between the axis of the dipole is theta. Angle between the direction of the armature field and the dipole axis is theta. Then what happens later? So because of the rotational effect, the dipole rotates, and finally the dipole will be aligned in the direction of the field. This dipole plus q and minus q will be coming like this. Will be aligned the dipole. Finally, the dipole initially is like this, and finally after rotation, this is plus q, minus q, and this is plus q, and this due to the torque, the dipole rotates, and finally the dipole will be settling in this direction. It is plus q and minus q. Finally, okay, with the field E bar. So the dipole rotates and finally aligns the direction of the field. Now let us take the theories. With the explanation of this diagram, let us write down these notes. Consider a permanent dipole with a magnitude of dipole moment. I told you, dipole will have a physical quantity, dipole moment. The magnitude of the dipole moment is 2a into q, is where 2a is the axis of the dipole, means length of the distance between plus q and minus q. Okay, kept in an uniform electric field, E bar means uniform electric field means strength of the field is everywhere it is same. That is the meaning of uniform electric field, E bar. Strength of the field, magnitude of the field everywhere is same. Theta is the angle between the axis and the direction of the field. Theta is the angle between the axis of the dipole, this is the axis of the dipole, axis 2a, and the axis, the length of the axis is 2a, axis and the direction of the field. Theta is the angle between E bar and the axis of the dipole. Okay. F bar is equals to Q bar, the force acting on the charge plus Q in the direction of the field. That is the basic theory. In the beginning of the field, it is given. So, if a charge Q is kept in the field E bar, force acting on the field is Q into E. And if the charge is positive, the direction of the force is a vector quantity, it has the direction. The direction of the force will be in the same direction as that of the field. If the charge is negative, then the direction of the force is in the opposite direction. Direction of the force, arrow mark indicates the direction, opposite direction of the field. Those two expressions are taken. Minus F bar is equals to minus Q E bar with the force acting on minus Q in the opposite direction of the field. Let us take for clarity plus Q. Okay. OB is the perpendicular distance between these two forces. Actually, OB is the perpendicular to 90 degree. Okay. Perpendicular distance between the two forces. Two equal and opposite forces now acting on the arms of the dipole, on the axis of the dipole, and the arm AB generates a torque. Torque means what? Is one which rotates the body. Okay. So on the dipole, actually two equal and opposite forces is called couple. Couple means two equal and opposite. The entities are there, they are called couple. Okay. Generates a torque on the dipole. Now let us calculate what is the magnitude of the torque, toe bar. Magnitude of the torque, toe bar is magnitude of the torque. Torque is denoted by the symbol toe. Magnitude means only toe is taken. Toe bar means you have mentioned both direction as well as magnitude. Let us work out the magnitude. Toe is equals to F into OB. It is the formula for torque due to couple. Last year formula, that is torque due to a couple is the force into the perpendicular distance between any one of the forces. Magnitude of any one of the forces. Two forces are there. No? Any one of the forces, magnitude of any one of the forces should be taken into the perpendicular distance between the forces. Okay, F is equals to Q into E. F is equals to Q into E. So OB is what? Look at the diagram. OB is equals to, so OB is equals to, consider the, here it is theta means it is also theta. Okay. So sin theta is equals to what? Sin theta is equals to opposite side OB upon hypotenuse. Here is 90. 90 means AB is the hypotenuse. Sin theta is equals to OP upon AB. Therefore, OB is equals to AB sin theta. Here is the diagram. Same diagram is written in the what it is by reversing the direction. So here is 90 at O 90 is taken, and at A theta is there, and B here it is. Then sin theta is equals to opposite OB upon what? The hypotenuse 2A. Therefore, OB is equals to AB sin theta. Therefore, it is OB is taken as AB sin theta. Okay. So, therefore, QE into AB is what? AB is equals to the axis, length of the axis of the dipole, that is 2A sin theta. AB is equals to 2A. In the diagram also it is mentioned. Okay, it is 2A. The distance is given. Therefore, 2AQ, it is 2AQ E sin theta. What is this 2AQ? 2AQ is P. Mention it is 2AQ is equals to P. P into E sin theta. P is sin theta. Therefore, tau is equals to magnitude of the dipole by that one. When a dipole is kept in an uniform electric field, automatically a torque acts on the body. This torque is one which rotates the body, which here the body is the dipole will be rotated. How much torque is acting? The torque is one which rotates the body. Vehicle wheel rotates by a torque only. Okay. So the torque tau is equals to P E sin theta, the magnitude of the what it is, the torque. Now torque is a vector quantity. Therefore tau bar is equals to, let us give the vector notation. It is tau bar is equals to continuation of equals to, it is P bar cross E bar. How it is? Last year we know that A bar cross B bar is equals to what? AB sin theta into n cap. Okay, AB sin theta into n cap, and therefore, and what is the magnitude of A bar cross B bar? Magnitude of A bar cross B bar is AB sin theta. Okay, AB sin theta. Therefore, PE sin theta is what it is? The magnitude of the torque toe bar. But what is the toe bar then? It is P bar cross E bar. A bar cross B bar is AB sin theta into n cap. N cap is the direction of the vector A bar cross B bar. A bar cross B bar is a vector whose magnitude is AB sin theta. Therefore, PE sin theta is the magnitude of the torque toe bar, and therefore A bar cross B bar is magnitude of A bar cross B bar is AB sin theta. Magnitude is there. PE sin theta means toe bar is equals to what? So it is A bar cross B bar. Okay. Therefore, toe bar is equals to P bar cross E bar. Therefore, toe bar is a vector. What is the direction of this toe bar? Not in the direction of P cap. So it is perpendicular to the plane containing the dipole. So dipole is actually a two. Here is the two charges plus Q and minus Q lying on this plane. Lying on this particular plane, say this is lying on this plane, then the direction of the torque is perpendicular to the plane. Okay, because A bar plus B bar is a vector perpendicular to the plane containing A bar and B bar. Here plus QE bar is in force F bar is in this direction, minus F bar is in this direction. Therefore, A bar plus B bar, torque to bar is P bar is what it is? Both P bar is from minus Q to plus Q on this plane only, and E bar is also in this plane. Therefore, what it is, you know that A bar cross B bar is a vector perpendicular to both A bar and B bar. Therefore, the torque to bar is perpendicular to the plane containing P bar and E bar. Actually, P bar is along this. P bar is a dipole moment is a vector quantity. It is in the direction of P cap. P cap is from minus Q to plus Q. It along this plane, along this page, and E bar is also lying in this plane. And now these two vector quantities are lying in this plane, and the cross product of that vector, those two vectors, is perpendicular to the plane. It's last year theory. If A bar and B bar are the two vectors lying in a plane, then A bar cross B bar is a vector perpendicular to the plane containing A bar and B bar. A bar ಈ plane ನಲ್ಲಿದೆ, B bar ಈ plane ನಲ್ಲಿದೆ. A bar cross B bar ಮಾಡಿದ್ರೆ ಒಂದು ವೆಕ್ಟರ್ ಬರುತ್ತೆ. A bar cross B bar ಅದು perpendicular ಆಗಿರುತ್ತೆ. Therefore, what is the direction of the torque bar? Perpendicular to the plane containing P bar and E bar in the outward direction. Okay, in the outward direction. The direction of the torque bar is the direction of the torque bar. The direction of the torque bar is perpendicular to the plane containing. It is the last year theory. I repeat, if A bar is a vector lying on this plane, B bar is a vector lying on this plane. Plane is a page is a plane, and A bar plus B bar is a vector perpendicular to this plane. Where that on that plane A bar and B bar is there. So if A bar and B bar are lying in a plane, then A bar plus B bar is a vector perpendicular to that plane in which A bar and B bar lies. Here both P bar and E bar are lying on this board. Say the diagram is taken on the board, and now torque bar is perpendicular. The direction of the torque bar is perpendicular to this plane, this board. Okay, in the outward direction. The word outward direction is to be taken. The direction of the torque bar is normal. Normal means perpendicular. Normal means perpendicular. Okay, perpendicular to the plane containing P bar and E bar. Containing P bar and E bar in outward direction. Outward direction. In outward direction means, so it is the plane containing P bar and E bar. It is either outward like this or outward in this direction also. Outward like this. Okay, outward direction. Okay, So the tow bar may be in this direction or in this side, in this direction. Both direction is possible. Okay. Means at a time both is not possible. So if the what it is, torque is in the clockwise direction, then the field is normally outwards like this. If it is in the anti-clockwise direction, it is like this. Okay. So just remember in the outward direction. So the torque, what is the SI unit of torque? The SI unit of torque is, so it is actually the unit of torque only. Torque is equal to actually force into distance, AB. Okay, F is in Newton, AB is in meter, Newton meter. Okay, SI unit of torque is same unit. SI unit of torque is Newton meter. Okay, Newton meter. And this torque, final one. So this is the end of the derivation. Here is the end of the derivation. This torque rotates the dipole. This torque rotates the dipole. Rotates the dipole. Finally, dipole aligns in the direction of the field. Aligns in the direction of the field. Okay. So magnitude of A bar, suppose A bar plus B bar is C bar. Okay. C bar is equal to A bar plus B bar. C is equal to AB sin theta. Tau is equal to PE sin theta. So C is equal to AB sin theta means C bar is equal to A bar plus B bar. Therefore tau is equal to B bar plus C bar. Therefore tau is written as P bar. Okay. C bar is A bar plus B bar. A bar plus B bar is a vector C bar. C bar is equal to AB sin theta. Okay. Therefore AB sin theta n cap. N cap is the direction. Okay. N cap is also unit vector perpendicular to the plane containing A bar and B bar. Okay. Therefore C is equal to AB sin theta. Magnitude of C bar is C. This is the magnitude symbol now. That's equal to AB sin theta. Therefore, it is not bad. C is equal to, C indicates simply magnitude. C is equal to AB sin theta. Tau is equal to PE sin theta. Therefore, C bar is equal to A bar plus B bar. Tau bar is equal to B bar plus C bar. Same. Indicate the comparison by confusion probability. C bar A bar plus B bar equals to AB sin theta. Therefore, C magnitude of therefore C is equal to AB sin theta. C is equal to AB sin theta means C bar is AB bar plus B bar. Tau is equal to PE sin theta means tau bar is equal to B bar plus C bar. Okay, very simple concept. Here is two equal and opposite forces acting. Best example is, so what it is, floor will be so rotated by the bend. Here is one force is acting in this direction and minus F bar is acting in this direction. So along this arm, the force is acting. So then by the two equal and opposite forces, not acting at one single point, at the what it is ends of the arm, two equal and opposite forces are acting. Then the arm rotates, means the wheel as a whole rotates. Here also same concept. Plus Q and minus Q are the two what it is charges of a dipole kept in an uniform field, where plus Q and minus Q are separated by a distance 2a, that is the dipole. Then when it is kept in a field E, then a force will be acting. F is equal to Q in the direction. In the field, if the charge is positive, the force is opposite direction of the field. If the charge is negative, automatically two equal and opposite forces acting on plus Q and minus Q. So two equal and opposite forces acting on a body. So where the forces are having a separation, then there will be a torque, means rotation effect will be there. Torque means rotational effect that rotates the what it is system. This rotation effect itself is called torque due to a couple. So here is torque on a dipole. What is the body here? Dipole. Why? the torque arises because it is kept in an electric field E bar, because of the dipole is kept in an electric field E bar. So any charge is kept in a field, then automatically force will be acting on the charge. Okay. Now let us take one simple example on this dipole. Okay, it's an example to do. Wait for a minute. ಏನು ಅರ್ಥ ಆಗೋದಿಲ್ಲ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಅರ್ಥ ಆಗಿಲ್ಲ ಬಿಕಾಸ್ ಆಫ್ ಯುವರ್ ನೇಚರ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ಕೂತ್ರು ನಿಮ್ಗೆ ಇದು ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ ಹೇಳೋದಿಲ್ಲ ನಾನು, ಆಯಿತಾ? ಇಲ್ಲಿ ಯಾರಿಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ಅಲ್ವಾ ಹೇಳ್ತಾ ಇದ್ದೀರೋ, ಯಾಕೆಂದರೆ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳುವಂಥ ಎಫರ್ಟೇ ಹಾಕೋದಿಲ್ಲ. An electric dipole with a dipole moment. An electric dipole with a dipole moment. An electric dipole with a dipole moment. An electric dipole with dipole moment. Dipole moment 4 into 10 raised to minus 9 coulomb meter. 4 into 10 raised to minus 9 coulomb meter, capital C small m, not cm it is aligned at 30 degree. Is aligned at 30 degree with the direction of the uniform electric field. With the direction of uniform electric field. Uniform electric field. Uniform electric field of magnitude is magnitude 5 into 10 raised to 4. 5 into 10 raised to 4 newtons per coulomb. Newtons per coulomb. Calculate the magnitude of the torque acting on the dipole. Calculate magnitude of torque acting on the dipole. Torque acting on the dipole. Nothing. Acting on the dipole. Okay. Torque is one which rotates the system. So here torque due to two equivalent opposite forces. Therefore torque due to a couple or movement. Torque is another name is movement of a force. Movement of a single force is the movement of a force. Due to two forces are the movement of a couple. Two equivalent opposite forces is called couple. Okay. So here it is, answer is here P, dipole moment is given as 4 into 10 raised to minus 9 coulombs meter. Cm, capital C, and field magnitude of the field E is equals to 5 to 10 raised to 4 newtons per coulomb, nothing problem. Torque to magnitude of the torque. Magnitude of the torque. Tau is equals to, here is the formula, Pe sin theta. Theta is given, theta is 30 degree. The dipole is kept at an angle of 30 degree with the field. Mention it in the problem. Torque Tau is equals to Pe sin theta. Okay. P is given 4 into 10 raised to minus 9, E is 5 into 10 raised to 4 into sin theta, sin 30 is half now, 4 into 5, 20, 10 raised to minus 9, 10 raised to 4, minus 9 plus 4, 10 raised to minus 5, sin theta is half, 2 ones are 2 tens are, 10 into 10 raised to minus 5, with a sin it, torque I told you, torque 2 is equals to force into perpendicular distance, therefore newtons meter. Okay, newtons meter. That's all. It's the simple problem. Okay. This year you expect some simple theories and simple problems. Okay. So I will come to the last section of that electric field. That is the Gauss's law or Gauss's theorem. Okay. So with the help of Gauss's law, Gauss's theorem, it has one or two, three important derivations are there. Three important derivations are there. One is omitted in this year's syllabus. Okay.